Okie dokie. Here we go. Adding and subtracting rational expressions. You need a common denominator. We just discussed that. Simplest way to find a common denominator is to multiply each expression by the denominator of the other. We talked about that when we did just the basic one. That's going to give us the CD, the common denominator. It may not give us the LCD, and we'll go through a couple of different examples. So, if I'm looking at this one, step 1 is factor everything. Step 2 is non-permissible values. Now step 3 gets a little bit more complicated. We got to find the common denominator, and then we have to multiply each side by them. So if we look at these, it's implied brackets here. They're implied brackets. So they don't share anything. So we're just going to multiply them by themselves. My word of wisdom, do not actually multiply them. Leave them in factored form. Okay? Like, don't actually do the multiplying. Just leave them as two factors multiplied together. So my LCD, so I want the denominator. I want the denominator to look like this. So in this first one, it's missing the x plus 1. So I have to times the numerator and the denominator by x minus 1. In the second one, it's missing the x minus 2. So I got to multiply both top and bottom by what it's missing. And then what we're going to do here, I didn't even finish this. We are going to, oh, that's a bad arrow. Just imagine that's an arrow. We're going to combine. So notice that I did multiply them through on the top. I did multiply them through here. We're going to combine like terms. So I'm going to be left with 2x squared plus x minus 6. I said it, but I didn't write it. Over x minus 2, x minus 1. Now what I'm going to do is I'm going to try to factor. Can I factor this after I've combined like terms? Negative 12 factors adding up to positive 1.
Oh, yeah,
4 and 3. So I'm just going to go to a different piece of paper. And I've got 2x squared plus x minus 6. So multiply the 2 and the x, I get negative 12. And then I have, we said 4 and negative 3. So 2x squared plus 4x minus 3x minus 6. I know I've done it correctly if these two are the exact same. My 2's are very different, but that'll work. So I get 2x minus 3 and x plus 2. So I'm going to hop back onto this one, and I got 2x minus 3 over x plus 2 over x minus 2 x minus 1. Is there anything I can cancel out there? They're different, right? Because one's a subtract 2, one's a plus 2. So I can't do anything here. But if I could, this would be the place that I cancel them out. Okay. So that's all the process there. So we're going to start with the one down the bottom. All right, step 1, factor everything. Doing some factoring on the bottom of the page. So again, depending on how comfortable we are with factoring, this is going to be hard or it's going to be easy, or it's just going to be long. And that's what these tend to be, is they tend to be more long than they do complicated. No, they get complicated. So next step is NPVs. So my next step is NPV. So I'm just going along the bottoms, denominators only. So here I've got plus minus 5, right? So x cannot equal plus minus 5. This one would be, can you do it in your head?
Positive or negative?
It's a 1/2 for sure, but is it positive or negative?
Positive, because it's an X, yeah.
So remember that we're always flipping the sign, right? So if it's a subtract inside, I know my answer will be positive. So it's going to be a positive 1/2. And then this one is a negative 5, but it's already stated, so I don't have to do that. Now, you might jump into finding your common denominator, but really we can reduce the fraction within itself. So if we look at this fraction right here, what can I, that's a terrible highlighter for that. What can I do to reduce inside of this? X plus 5, same on top and bottom, right? So gone and gone. So now that's going to be 3 over x minus 5. If you're able to simplify within the fraction, do it. It'll make your life so much simpler. If you simplify up front versus at the end, it makes your life, you're so much smarter at that point. So this one, I'm going to cancel out the 2x minus 1, so I'm left with plus 2x plus 1 over, I don't know why I put that one in brackets and the other one I didn't. So I'll go back and put that one in brackets. All right, so now that I've simplified, what's my LCD? Perfect. So all you did was take the two denominators and you just times them together. Now my words of wisdom to you is actually don't times them together. Just leave them in factored form. It will help your brain. Again, don't do more math than you have to do. So in this first fraction, what's missing out of the LCD in the denominator? You got these two. It contains one of them. Which one is it missing? X plus 5. So that means we multiply top and bottom by x plus 5. Because x plus 5 divided by x plus 5 just has a value of 1. So we're not changing the value, we're just changing how it looks. How does it make you guys feel? Okay. All right, what's missing from this fraction? X minus 5. So top and bottom. And then the trouble is when we switch to 6.4, we use a very super similar strategy, but it's completely different. In expressions, we're multiplying top and bottom by what's missing. And in equations, we're multiplying tops only by the whole LCD. Very confusing. Okay, let's do some math. Let's multiply some things and not multiply things. I want you to multiply any of your numerators. But I want you to keep your denominators in factored form. That's exciting, eh? Aw, boo earns. Thank you. That is a mistake. But it's like it never happened, except we're recording it. Tyler's. He's good. It's no point in going on. it's gonna cry, it's gonna be bad. All right, so now when we are adding fractions that have the same denominator, all we do is add their numerators and keep that denominator. So that's no different than regular math. I've run out of room, so I'm gonna move up here. So I have 2x squared, and then I have a 3x, and x is 4x minus 10, so it's gonna be negative 6x plus 10. All over my common denominator. Let's see if I get it right this time. Can I factor that numerator? I think I can. What am I going to do first, though, before I get into binomial factoring? What can I take out of every term?
2.
I can take a 2 out, and that's going to make things a little easier on my brain. And really, that might help us see if it's factorable or not. Is that factorable, that x squared? What are the factors of positive 5 that get us to negative 3? 5's prime, right? So 1 and 5. And they both have to be negative. So is that factorable? No. Not easily anyway. Again, if you're using that quadratic app or any quadratic app, so if I put it in mine, so that was 2x squared negative 6 plus 10. Now mine won't show me all the steps for factoring. And see these eyes in, can't see those. See the eyes in my answer? That means that it's imaginary and there's no solution. So that one's definitely not factorable. It's telling me my discriminant. And what's my discriminant? It's a negative. That's the stuff under the root sign in the quadratic formula. That's a negative 44. So it's not, and it's telling me it's not factorable over real numbers or integers. So that's what my app tells me. It doesn't show me the steps. And this guy was free. Not helpful on a test or a quiz, but definitely helpful if you're doing a problem set or are unsure of how, is this factorable? Go check. So this is where we would stop. This is it. That's my final answer. Where x cannot equal plus minus 5 and 1/2. Now you don't have to repeat that because we've got it nicely stated up here and labeled, but you can always include it. There should have been a comma and then that restrictions after. How do we feel about that? Terrible? Kinda? It's just a lot of stuff. Okay. Oh, the monomials are the worst. But that's okay. We're smart people. We can figure it out. What's the denominator on the 3 before we start?
1.
It's a 1. I like to write that in there just to remind me. So step 1 is factor everything. Yay, it's already done for us. Step 2 is NPVs, and they're all monomials. So what can x not equal if it's a monomial? 0. Anytime it's a monomial, it's always going to be 0. So then y cannot equal 0. X squared, we would have x squared equals 0, square root both sides. What's the square root of 0? And if that's already stated, so I don't have to repeat it for that one. And there's no variable here, so there's no restriction on this. Okay, good job everybody. We factored, we did our non-permissible values, and now we're going to do our LCD. Okay, I I want to use the LCD. Okay, what would be the common denominator, everybody? Let's go with that. Everybody would agree with that? That would be our common denominator. We just multiply them. Okay. Pretty exciting stuff. I don't know if I want to show you the LCD on this one. I'll come back to this in a second. We'll do it this way for right now. All right, so I just want to point out that I'm using a common denominator, not the LCD in this one. I'll go back and show you the difference between the two. So what we want to do is, what do we want to times this 2x, this fraction by?
X, y.
X, no, it has the xy. It needs the
X squared.
Hey, why didn't I multiply it by 1?
It stays the same.
It's going to stay the same, right? It's kind of redundant. You can put it, it's not wrong, but multiplying anything by 1 is just itself. So I'm just ignoring it for right now. So I've got to times x squared over x squared by 2x over xy. And then what do I have to do for the next fraction?
X, y.
So this one's the xy. And then minus 3. What does it have to have?
Both of them.
Both of them. Ooh, that's supposed to be a squared. I was getting ahead of myself. Okay, guys. Let's multiply things. Okay. I have 2x cubed over x squared times xy plus 4x squared y over x squared xy minus 3x cubed y over x squared. Ooh, I forgot my x in there. xy. In mathematically, grammatically correct stuff, we usually do them in alpha order, just so you know.
What you do.
Just I do xy instead of yx. Okay. Is there anything in the numerator that I can combine?
The X squared. Oh,
Because this is numerator. Numerator. So this is an x cubed and that's an x cubed, but this is an x cubed y and this one's an x cubed. So two different types of variables. So there's nothing I can combine there. So I've got 2x cubed plus 4x squared y minus 3x cubed y over x squared times xy. Ladies and gentlemen, is there something I can common factor out of the numerator? An x squared. Can't take a y, but I can definitely take out an x squared. So if I take out an x, maybe I'll go up here. If I take out an x squared out of the numerator, that would leave me with 2 plus 4y minus 3xy. Oh yes, you're absolutely right. Sorry. Thank you for catching that. X squared, xy. Now what could I do from here? I can simplify something. What's the same on the top and bottom that you see? Nope, not the xy's, because the xy's, the x squareds.
It's also got to be the same coefficient.
Mm-hmm. What do you mean the same coefficient? Sorry.
The xy. As if it was like, maybe.
But this, see how these are all added or subtracted? This xy has to go into here, and into here. So I can't just take it away from that one. The reason why the x squared is multiplied by this. So an x squared lived in all of these. And that's why I can cancel out the x squared, because it lived in all those terms. And that, ladies and gentlemen, as ugly as it is your final answer. So this is the uncomfortable part, because that doesn't look right. That doesn't look simplified. It looks gobbledygook. It doesn't. And that's the uncomfortable part of this one. Like, if x could equal 2, then I'd be like, okay, that makes sense, or reject that answer, or whatever. But these ones just don't feel as comfortable. Okay, easier one. You guys are like, it does not look easier. Step 1, factor everything. Can I factor that numerator? Is 20 a perfect square? So we're not going to. We're just going to leave that the way it is. But I can factor its denominator. What are my NPVs? Plus minus 2. Nice and easy. Nothing I have to do special there. I hope everybody feels comfortable with that step at least. You guys are going to have a quiz on all of this on Tuesday. But Monday is no new lesson, if that makes you feel better. Okay, so let's talk about it. A common denominator would be if we multiplied this denominator by that denominator. But just like the example that we did, that 4 and the 2, what's missing out of this one? The y minus 2, right? So my LCD at this point, so now it's my lowest common denominator because I'm getting smarter and I'm saying, hey, the y plus 2 lives in both places. I don't need to multiply by that factor. The only thing I'm missing is y minus 2. So this fraction, I'm not even going to touch because it already has the denominator I want. This fraction, I'm going to times by y minus 2 over y minus 2. Okay. First one's nice and easy. You're going to get so tired of writing things over and over again. Now I'm going to go ahead and I'm going to multiply the numerators together. Remember, it's implied brackets, so I'm going to have to do my foiling, my leapfrogging, my distributive property, whatever you want to call it. And I skipped a step there, but I think you guys are probably okay with that. Okay, now they have the exact same denominator. I can go ahead and add their numerators together. Having a hard time doing some mental math here. And I'm not going to multiply my denominators. It's not who I am, it's not what I do. Can I factor that numerator?
Yeah, we can take out a 2.
We can definitely take out a 2, and if we take out the 2, then I can probably answer my question a little bit easier. So y squared minus 2y minus 8. Can I factor that trinomial?
Plus 4 and negative 2? Or is it
Negative 4,
plus
positive 2. Yep. can I simplify it even further?
Yeah, but plus these will make
So those are gone. So I'm left with 2 bracket y minus 4 over y minus 2, where y cannot equal plus minus 2. That one was pretty gentle. That one was pretty nice. That one feels like a little bit more complete. We did some stuff, we simplified it. It looks better than that monomial one.
Why is it on plus or minus?
Because we always do our non-permissible values before we cancel anything out. So we would have done them at this stage. So they would have been here,
Oh, right.
right? So we always have to do the non-permissible values before we simplify. Okay. It is never a good thing. Well, when I give you one question on a page.
fraction
We've been there before. You've survived it before, so I can only assume you're going to survive it again. Okay, these look really terrible, but if you break them down, they're not too bad. I treat them as 2 separate things. I treat them as my numerator and my denominator. And what math are we doing between a numerator and a denominator?
dividing.
We're dividing them, right? So if I write it out like that, all of a sudden, this doesn't seem so bad. Because I have a fraction here. And I've got a fraction there. So when I'm starting this equation out, I like to just treat them completely separately. I like to work the numerator, get it down to a single fraction, work the denominator, get it down to a single fraction, and then divide them by multiplying by the reciprocal. So the goal is to get this and this to a single, like this one turns into a single fraction, and separately that one turns into a single fraction. That's my goal here, is that's what I want to do. I want to get them to have common denominators. So I have one numerator and one denominator over here, and one numerator and one denominator over here. So you got fractions inside fractions. It's kind of a pain in the butt. Denominator on that 1 is 1. So what are, it's factor everything. Obviously there's nothing to factor. What are my non-permissible values? X cannot equal, if it's a monomial, 0. Nice and easy. What's my common denominator on this side?
One.
What do we do with these? We just multiply them.
1x.
1x. So my common denominator on this side is 1 and x. Do I need the 1? No, because anything times by 1 is itself. But if it makes you feel better and it makes this more clear in your head, then definitely do it. I've done it for a bunch of years. I'm kind of getting good at it, so I feel confident not to have the 1. This is your first time doing it, so. Okay, so this one already has the x. This one needs the x, so I'm going to multiply top and bottom by x. So I have x over x plus 1 over x. And if I combine those, 1 plus x over x. It's pretty exciting, right? So did I get it to a single fraction? I have one numerator, I have one denominator. My task for the big numerator is done. Now let's walk over to the denominator. All right. What are my non-permissible values? 0. It's already stated, so I'm just not going to state it again. Is everybody okay with that? And what's my common denominator on this side?
1x as well.
1x as well. Now, in this situation, these are both the same common denominators, but they don't have to be. Like in some questions you'll get, the common denominator over here will be different than the common denominator over here. Just know that there's other options. So I got to times this guy by x over x. So I'm going to have x squared over x minus 1 over x. And if I complete that, that's going to be x squared minus 1 over x. Did I get the denominator to a single fraction? I have. Does anybody have a burning desire to factor that before we go any further? Does everybody see right away that you can factor that difference of squares? Plus 1 minus 1. You can do it now, but you're going to have to do it later, so it doesn't really matter. So remember that numerator is divided by the denominator. So this is divided by that. This is a 6.2 question now. What do we do? Step 1, factor everything. Step 2, non-permissible values. X equals 0, or x cannot equal 0. We already got that. That's up at the top. Step 3. What do we do with division questions?
Reciprocal.
Multiply by the reciprocal. Hey, you got a new denominator. What do you got to do?
Multiply by.
No,
So,
we're multiplying, so we don't need common denominators.
oh,
Yep. So we have a new denominator, so that means we have to revisit our NPVs. So what are we adding to our NPVs?
plus minus 1.
Yeah, I'm just going to slide back up here because I'm being a little lazy. Plus minus 1. Okay, slide them back down. What do I do now? I cancel stuff out. Cross stuff out. Super exciting. The plus ones can go. What else can go? Yeah, the x's can go. So what's on top?
1.
1. Some people forget that x divided by x is 1. X plus 1 divided by x plus 1 is also 1. So this guy's still in the basement. He's still in the denominator. Our numerator is 1 over x minus 1, where x cannot equal 0 plus minus 1. So people hate these questions because they look super complicated, but if you actually separate them into things you can manage, these were probably the nicest adding and subtracting that we've done. There was like one denominator on it. You will have this question on your test and on your quiz. Not this particular question, but you will have a fraction inside of a fraction question. Okay, that's it. Done.